Hi, welcome back, or if this is your first time here, welcome to the Q&A channel. I'm your host, Professor Qanda. In this episode, I'm going to explain what the differences are between low Earth orbit and traveling to the moon and beyond. So, sit back and enjoy the video. Remember to hit those like and subscribe buttons to help out the channel. Let's get started. Imagine leaving Earth, not just in a plane, but pushing all the way into space. At first, that journey might not seem so extreme. Astronauts in low Earth orbit, where the International Space Station operates, are only a few hundred miles above us. From that distance, Earth still feels close. Communication is nearly instant, and if something goes wrong, astronauts can return home within hours. But even here, space is unforgiving. In low Earth orbit, astronauts live in microgravity, which slowly weakens muscles and bones. They're exposed to radiation, though Earth's magnetic field still offers significant protection. One of the biggest dangers is space debris, tiny fragments of metal moving faster than a bullet. Even a speck can cause serious damage, so spacecraft rely on shielding and sometimes have to maneuver. Now compare that to traveling to the moon. The moon is nearly 1,000 times farther away than low Earth orbit. As a spacecraft leaves Earth's orbit, it also leaves behind the planet's protective magnetic field. That means much higher exposure to radiation from the sun and deep space. A powerful solar flare during the journey could be life-threatening. Distance changes everything. It's a massive challenge. Communication delays stretch to a couple of seconds each way, and emergency rescue is no longer realistic. Astronauts must rely entirely on themselves and the systems they brought with them. Landing on the moon introduces new challenges. The surface is covered in fine, abrasive dust that sticks to everything and can damage equipment. Temperatures swing between extreme heat and cold, and the moon's low gravity affects movement and long-term health. Even returning home is harder. Spacecraft re-enter Earth's atmosphere at much higher speeds than from low Earth orbit, creating intense heat. This is where modern missions come in. NASA's Artemis II was designed to send astronauts around the moon for the first time since the Apollo era. Unlike earlier missions, Artemis II is not just about reaching the moon. It's about testing the systems needed for sustained deep space exploration. It will validate life support, navigation, and communication in an environment far beyond low Earth orbit, laying the groundwork for future lunar landings and eventually missions to Mars. It marks a transition from short trips close to Earth to long-duration missions. In many ways, it's a rehearsal for the future of human space exploration. But with renewed interest in lunar travel has also come a resurgence of old conspiracy theories. Some claim that the Apollo 11 moon landing was staged. These ideas often point to misunderstood details, like shadows in photos or the way the flag appears to move. However, these claims don't hold up under scientific scrutiny. The lighting effects are consistent with a single distant light source, the sun, and the flag's movement is explained by the lack of atmosphere. More importantly, the evidence for the moon landings is overwhelming. Independent tracking stations followed the missions. Reflectors left on the moon are still used today. Thousands of engineers would have had to maintain a decades-long, flawless cover-up, extraordinarily unlikely. With the Artemis II mission, some theories suggest new missions are attempts to prove something. In reality, these missions are about advancing technology. And then there's the red planet, Mars. It's a whole new scale. If the moon is a major leap beyond low Earth orbit, Mars is an entirely different scale. The journey takes months instead of days. Astronauts face prolonged radiation exposure. Communication delays can stretch up to 20 minutes each way, making real-time support from Earth impossible. There's no quick return. Missions must be timed precisely. Astronauts may have to stay on Mars for months. Every resource, air, water, food, must be carefully managed or produced on site. A single failure could be catastrophic. Even landing is a challenge. Engineers call the descent the 7 minutes of terror, where everything must go exactly right. So, while low Earth orbit is the edge of Earth's neighborhood, the moon is deep space, more dangerous, isolated, and far less forgiving. Mars pushes exploration into a realm where survival depends on complete independence. Each step isn't just a little harder, it's exponentially more difficult. And with every increase in distance comes a dramatic rise in risk and in what we stand to learn. Well, there you have it. I hope you enjoyed the explanations. Before you go, hit the like and subscribe buttons. It really helps out the channel. This is Professor Q&A saying thanks for watching and bye for now. See you in the next Q&A channel video.